a road that cuts through the mountains, or where they decide to put a dam that makes a reservoir. Well, all this and more is covered in the subject of land surveying. And today we're in northern Colorado at 7,500 feet, and we're going to take you on an example of doing land surveying with an unmanned LiDAR system. So stay tuned and learn all about it and more on today's video. Let's go! Alright, we're loading up the truck. We got all the gear here. Today we're going up to the mountains in Colorado. We got a job where we're doing a LiDAR survey of a local watershed in order to generate a digital elevation model and contours. And we're delivering this to a civil engineering firm who's going to use this data in order to make plans for work they're doing along the roadway. Let's continue loading up the truck and get going. Well, we just pulled up. It's starting to rain here. Before we start flying today, I want to tell you, basically we have a whole system for doing these LiDAR land surveys, and they consist of these three basic big steps. The first step is we have to go out and get ground control points and set up aerial targets. In the second step, we plan and fly the mission. And in the third step, we take the data from the first and the second step back to the office, and we process it together. But before we do any of that, we got to get out of this rain, and we're going to use some of this time to go and inspect and scout out the area before we start flying. We're walking the job site right now. You can see behind me is a lot of trees. The client wants no trees in the data set, so it's just this topographical map of only the ground. And we also need to find a good place to go take off and land from. Alright, this looks like an ideal place to fly from. And what makes this a good place is that there's no overhead obstructions like trees or power lines, and we have a really good view of our whole flight plan. So let's go ahead and jump into our first step, and that's setting up the base station and starting to collect some ground control points. So this right here, this is our base station, and it's going to be collecting data the entire time we're out here. And this is the GPS rover. It's communicating with the base station at all times and enables you to get 2 centimeter precision on all the data it records. Now to tie this into the sky, we need to paint some aerial targets that will be visible to the LiDAR data recorded from the drone. This aerial target will show up very bright in that LiDAR data. Now let's record the accurate location of where this is located. Got it. So we just finished capturing our last ground control point. Now we can go back to the drone, plan the mission, and take off. This right here, this is the LiDAR. Let's get it installed here. Now we can go ahead, start flying and getting data. Right now, flying 100,000 laser pulses every second. flight line. We're going to bring it home, land it, switch out the batteries, and pop it back up. All right, we just finished doing that drone flight. Got all the LiDAR data, got everything packed up. We're going to head back to the office now, process the data, and show you all what it looks like. Let's go back to the office. Welcome back to the office. We just got done flying the LiDAR drone and collecting the ground control points, and now we're taking both those data sets, putting them together to derive our results. So let's go ahead and just jump right into that and take a look at that raw point cloud data. Here we're having a look at that first LiDAR data. It looks freaking awesome. So right now what you're seeing, if you don't know, this is the raw point cloud data. The red is high, the blue is low, and the color is depicting elevation. If we scroll around a little bit, you can see a lot of detail, a ton of detail in this data. This is what you're going to get with unmanned aerial LiDAR data collection. It's very high resolution, very high detail, and very high fidelity. Now let's go ahead and take a look at the accuracy of our LiDAR data. In order to do that, we're going to look at the intensity view of the LiDAR data, which will reveal the aerial targets, and then we'll be able to compare those aerial targets to the data we captured from the GPS RTK system. I just imported the ground control points into the data set, so now we're going to be able to see them laid right on top of the intensity view of the LiDAR data. Here's our first aerial target. Now I'm going to go ahead and look straight down the plane of the data and just see where that target falls. It looks like it's right in the middle. Now in order to get an even better perspective and view, we can do something called a cross section, which is taking a little slice out of the data. And then we can actually see the point laying in the data. It's a little big right now. Let's shrink that down. Okay, so it's basically inside the data set. I'm going to go ahead and calculate. So even to this middle point, we're at 0.036 feet off. So 0.036 feet, this is about 1.1 centimeters. We're spot on. Let's go ahead and take a look at one more ground control point, and then for the rest of them, I'm going to go ahead and just calculate them all off the video. Here's the aerial target that you saw me paint on the ground. And again, the point is basically right in the center, so it's good on the X and Y axis. Let's look at the Z axis. All right, the closest neighbor here is about 0.04 feet away. Now, 0.04 feet is 1.2 centimeters. I went ahead and calculated the error from all the other ground control points throughout the whole data set, and they were all about 1 to 2 centimeters. So this looks really great for the global accuracy of the data, and the precision is about 2 to 3 centimeters. So I'd report this to be about 2 to 3 centimeters precise and accurate across the whole data set. Okay, now you've seen the data, you've seen the accuracy of the data. Let's go ahead and look at the ground classified portion of the LiDAR data set. This is stripping off all the trees, all the vehicles, everything that's not ground. And you can see there's an incredible amount of density of data outlining all of the ground throughout the entire data set. This is actually what's unique about LiDAR data. You don't get this doing photogrammetry, because when you do photogrammetry, which is photos, and you stitch those together to make a 3D model, you have all the trees, and the trees are just blocking the ground, and you're not seeing the ground really well. But with the LiDAR data, we're able to actually get points to the ground underneath the canopy of the trees. Then from this is what we're going to derive the digital elevation model. So let's go ahead and just jump right into the digital elevation model for this data set. This is the digital elevation model for the data set. It has no trees, just the ground, and it's a TIFF representation of the LiDAR data. This is very easy to import into other software because it's only an image. It's not the raw point cloud data. It's just an image of the heights associated with the ground. And for this, I did a 1 foot spacing and interval for the DEM. We actually have something really unique with this software. We can turn the DEM into a 3-dimensional model as well, and it looks really cool. I'm going to go ahead and just take that 3D view of this data and put it in right now so you guys can see exactly what that looks like. It looks really awesome. I mean, you can see some, I didn't even know what this is, some sort of road, but there was no road that was over there. I walked over there. So this is maybe some sort of drainage feature. And over here, underneath all these trees, there's a couple more drainage features as well. Very important information here. Now, the final piece of information we want to derive from this data here is a 1 foot contour model. I'm going to go ahead and show you what that looks like now. The yellow lines are 1 foot intervals, then every 5 feet you see a blue line, and every 25 feet I have a red line. It looks very detailed, very accurate. And we're also able to import all this data into CAD as well as GIS software. And so I think it's actually an important thing to show you right now. I'm going to go ahead and import these contours into QGIS, which is an open source free GIS software. And you can see right now that it lines up perfectly. If we go ahead and turn on a Google hybrid base map, you can see all of the contours line up with the area that we were surveying in. Now, our ground control points are definitely way more accurate than the base map from Google Maps, but it still does a good sanity check for you to see your data overlaid on something else like Google Earth and Google Hybrid. All right, well, that was the unmanned LiDAR land surveying video. Hope you guys enjoyed it. And you know what? I did something really special for this video. I went ahead and hosted that data set online. So if you look into the notes in the description below, you're going to see a link right there, and that will lead you to seeing that data set for yourself.